Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 6th grade topic, the spread of your data. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today or even your own homework, remember, visit my Facebook page at Tutor Me Sempai and tell me all about it there. Today's video is going to have 3 parts. So leave a like, smash the subscribe button, and let's get started. Previously on this channel, we've talked about the shape of your data, we've talked about the center of your data, and today we're going to be talking about the spread of your data. And to do that, we're going to discuss 4 things: the range, the IQR or interquartile range, the variance, and the standard deviation. Each of these will help us describe how your data is appearing in your data set. So let's start with the easiest and simplest one first, your range. Now, by this time in mathematics, you are probably familiar with your range that looks like this. So you have some number, let's say 1 and 5, and you have that comma in between, and this will tell you this is going to be all the numbers between 1 and 5. You have a range of numbers. Well, that's not quite the range that we're talking about today. The range that we're talking about today, the statistics range, is going to be one number, whereas usually your range is multiple numbers. The range that we're talking about today is going to be one number, and it's going to be the distance between your lowest number in your data set and your highest number in your data set. So let's say we did have that one back here, right? And you had a bunch of numbers in this data set, and this was your lowest, that's your lowest, and this one was your highest. Your range is going to be the difference between these 2 numbers. So it will be 4. So regardless of what's happening in between 1 and 5, your range is looking at the outside number, your extreme numbers on either end, and finding the difference between them. Now, because range is so simple, it does have some pretty easy uses. So for example, let's say that you were job searching. You were looking for a job. You have a desired salary. So your desired salary, you're pretty qualified. You want $95,000. $95,000 for your desired salary. And you're looking around and you find this amazing looking company. So I'll say company A. Company A, and company A has 2 positions. So both positions are something you qualify for. You fit both of the prerequisites. Position 1 and position 2. How do you know which one you want? Well, company A might just give you some salary information to help you. So let's say position 1 has a salary range that goes from $40,000 to $100,000. And position 2 has a salary range going from $80,000 to $100,000. You notice both of these positions you not only qualify for, but they are also including your desired salary. Which one do you choose though? This is where range can come in. Range, once again, is telling you how your data is spread. So if you were to find the range of each of these, so position 1, let's say P1, has a range of 100,000 minus 40,000, which equals 60,000. P2 has a range of 100,000 minus 80,000, which equals 20,000. 60,000 and 20,000, your 2 ranges. One is a decent bit higher than the other. The bigger your range, the more spread out your data is. That means, in this case, the more salaries that are going to be found between 40 and 100,000. So if your desired salary is 95,000, you're probably going to pick position 2. It has a smaller range, which means you're more likely to get your desired salary or something close to it. if you pick position 1, there's a lot of variation between that data, and you might not necessarily want to chance it and get something way below your desired salary. So without really knowing much more about the data, you can make a nice easy choice using your range. So it's simple to find and has a very easy to see use case, but because it's simple, range also has a very easy to see shortcoming. Let's say you're still in that job search and you found another company that looks pretty much just as good as company A. And you already really like that position that you saw, that range from 80,000 to 100,000. But company B also has a position that has the same exact range. How do you know which company to choose? Well, your range doesn't tell you anything more than how your extremes are looking. You have no idea how the actual data within your data set is falling. That's where your shortcoming is for your range. But if you were to move on to your IQR, you may get a little bit more information. Let's see how. Your IQR, or interquartile range, as you see, it's another range. However, it doesn't look at the extreme values, your first and your last value of your data set. It looks at the middle 50% of your data. Depending on how big or small that is, you'll see how your data is falling. So here we have our range information, but we need a little bit more information to find our IQR. So let's say both of these companies have data sets that look like this. Now these are going to be shorthand for thousands. So when I say 80, I mean 80,000, 100, 100,000, just to give us a little bit more space to work with. So your data is going to look like this. Your salary data for company A is going to have 80,000, 81,000, 82,000, 83,000, 84,000, 97,000, and 100,000. That's our data set that comprise the range that we looked at. Company B looks a little different. You have 80,000. Once again, we're starting at the same place. Remember, it had the same exact range. So 80,000, 90,000, 93,000, 94, 96, 98, 98,000, and 100,000. So it's a little bit different. So you see, you can have different looking data and have the same range. That's also another shortcoming. Your data can look very, very different and your range won't tell you anything about that. However, if we look at the IQR, your interquartile range, you get a little bit more information about how your spread is for each company. And how you find that out is first you have to start with finding your median for each data set. So looking at our data set, our medians are going to be 83 and 94. Now from your median, you're going to look at the first half and your second half of your data. And then you're going to find the median for each of those sections. So over here we have 81, 97. Over here we have 90, 98. Once you found those medians, you're going to subtract them. So you're going to have 97 minus 81, and you're going to have 98 minus 90. Now when you subtract these, you're going to get what? 16, 8. And remember, this is in thousands. So the interquartile range here is 16,000 versus 8,000 for company B. Your data is going to be more spread out within your middle 50% in company A than it is going to be in company B. And you already know what your median is. So if your data is really spread out and your median is at 83,000, your desired salary is 95,000. Well, that's not really looking too good as far as your potential of getting your salary. It's pretty spread out. That means you have a lot of different chances to not hit that 95,000. And your median is much, much lower than that. Here, your median is pretty close and your data is pretty packed. So you have a very, very high chance of getting your desired salary if you choose company B. That's why your interquartile range is going to be a bit better than your overall range, because it really focuses on the middle 50% where things are probably going to be more grouped together to show you more likelihood of something happening. However, even your IQR is not going to be the best way of finding your spread of your data. You can probably get a little bit better using one of two other things: your variance, or probably even better than that, your standard deviation. So let's move on to that. Where your range and your IQR give you a broad idea of how clustered your data is going to be, how grouped together it may be, your variance and standard deviation will give you a better sense of how each data point is going to be spread amongst each other. And because variance and standard deviation are so interconnected, so dependent on each other, I'm actually going to cover them both in the same section. Now, I'm not going to give you any actual examples with data to find or calculate your variance or standard deviation, but I will give you a broad idea of what your variance and your standard deviation are. Well, unlike your range and your IQR, which depend on finding your endpoints and finding your medians, your variance and your standard deviation will depend heavily on finding your mean. Now, we've already talked about in another video about how your mean can be skewed when you have skewed data, but even if you have skewed data, your variance and your standard deviation will give you a good idea on how, on average, things are looking in comparison to each other. Obviously, without skewed data, it's going to look a little bit better than with skewed data. And here you have two examples. A data example with skewed data and one without. Notice our outlier right here. That's our outlier. So let's just assume that these 4 points are the same exact points here. I'm just removing the outlier in this case. If you were trying to find your variance, let's start there. Finding your variance requires you to find the distance between each of your data points and the mean. So first you want to find your mean. Find your mean. Then you want to find the distance. So find the distance from each point to the mean. That's what we did here. Each of these data points, this line, this purple line, connecting them to this dashed line, our mean line, is going to be finding the distance from each point to the mean. After you do that, you're going to want to square that distance and then average those out. Doing all of this will give you your variance, which we denote with sigma squared. However, sigma squared actually also squares your unit. So whatever this mean is, let's say it was kilograms, your sigma squared is actually going to be your kilograms squared. So when you're trying to talk about the data, the spread of this data, and you're using your variance, it's not all that clear what kilograms squared means. What's that? How's that relating to your actual data, which is in kilograms? That's where standard deviation comes in. It takes your variance and your SD is going to square root it. It's the square root of your variance. You see, they're interconnected here, which leaves you with just sigma. So if sigma squared was kilograms squared, your sigma is going to just be kilograms. Now you can more easily talk about the distance between your data points because your units are going to be in the same units as your data points. Now this may look a bit confusing, but it gets a little bit simpler when you start dealing with actual numbers. So once again, I will make an actual video on how to find your variance and your standard deviation later with some examples, but I want to give you a high level view of what your variance and standard deviation are going to be. But I also want you to take a note of how your outlier does affect both your variance and your standard deviation. When you have an outlier, it's going to shift your mean. So remember, we're assuming that these 4 points are the same as these 4 points. So if your mean is here because of your outlier, and removing your outlier drops your mean, now it's going through some points, and you see your distances are going to be a lot closer because these are bunched together a bit more than this outlier was. This is going to have an impact. Remember, everything depends on the mean. If your mean is up and you have bigger distances, your variance and your standard deviation are going to be bigger as well. So when you're dealing with skewed data, just keep in mind that your outliers are inflating your variances and your standard deviation. However, it's still going to be a bit better than your ranges and your IQR when trying to determine how they're falling in respect to each other. So I hope you were able to follow along with today's video, and I hope you know a little bit more about the spread of your data. However, if you have any questions about what you saw today, or even your own homework, hit me up on my Facebook page, @Tutor Me Sempai, and tell me all about it there. If you hadn't done so already, hit that like. It surely helps the channel by letting YouTube know that you found a video helpful. And if you found a video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney, and this has been another session of Tutor Me Sempai.